Example 2 or problem 2 says a point P is shown on the unit circle corresponding to a real number t. Find the values of the trig functions. Now when it says trig functions, underline that on your notes. Trig functions, there are 6 trig functions. There are 6 trig functions. So on number 2, they've got a little diagram. So if you will, T is your angle. So the angle has rotated all the way to this point. And this point has an ordered pair of -5/13 and -12/13. What's the x value in that ordered pair? What's the x value in that ordered pair? -5/13. What's the y value? -12/13. So this is how you find these values if you're on a unit circle. So we're going to kind of write them like this. You might have to write small. So the sine of angle T, we're going to abbreviate that sin, is the y value at the point of rotation. So what's the y value at the point of rotation? -12/13. So sine of angle T is -12/13. Cosine of angle T is the x value at the point of rotation, which would be -5/13. And then I wrote cotangent and I meant cosine, my bad. So what I do is I do these in order. I do sine, cosine, and then I do tangent. Alright, tangent is y divided by x. You can do this in your calculator if you want to. I would suggest that you do this in your calculator. It's -12/13 divided by -5/13. It's y divided by x. And you get 12/5. Okay? Not going to write that step down. Tangent is the y value divided by the x value. And then I use my reciprocals. Right beside sine, I write cosecant. Cosecant is the reciprocal of sine. So I just flip 12/13. I just flip it over. So my cosecant value would be -13/12. Secant is the reciprocal of cosine. So I just flip 5/13 over, keep the sign. So secant would be -13/5. Cotangent is the reciprocal of tangent. So cotangent would be what? 5/12. So what I do is I think about sine, cosine, and tangent. I actually think about those. And for cosecant, secant, and cotangent, I just flip sine, cosine, and tangent over. I take the reciprocal of those. Alright, makes it pretty quick. Any questions about number 2? So when the directions say find the values of the trig functions, there are 6 trig functions. So you're going to do the first set of directions. Alright, we're going to jump to number 6. The directions change. It says, in exercises 5 through 18, the unit circle has been divided into 12 equal arcs corresponding to t values. So I've written there are no, what kind of angles on this circle? There are no 45s. That's what they're trying to tell you. There's no 45s drawn in. They're actually there, but they didn't draw them in. So don't get confused. They've left the 45s out of this diagram. So it says use the x and y coordinate in the figure to find the value of each trig function. So this time we only get to find one thing. So for number 6, they're asking us for the sine of pi/3. Alright, so sine is yx or y/x. You already forgotten? Sine is the y value. Cosine is the x value. Tangent is y divided by x. So number 6 are asking you to rotate to pi/3 and give me the y value. Sine of pi/3 means rotate to pi/3. Sine means give me the y value. What's the y value at that point? Square root of 3/2. So this section will be a little bit simpler because they're not asking you for all 6 trig functions. They're just asking you for whichever one is in the problem. Alright? Number 8 is asking you for the cosine at 2 pi/3. So you're going to rotate to 2 pi/3. So in your mind, you're rotating to 2 pi over 3. Do you know where that is? Which quadrant is 2 pi over 3 in? If they don't have it marked, you've got to rotate to 2 pi over 3. What quadrant is 2 pi over 3 in? Second quadrant. What's the ordered pair at 2 pi over 3? Comma, square root of 3 over 2. So what's the cosine at that ordered pair? Negative 1/2, because cosine of the angle is the x value only. Sine is the y value, cosine is the x value. Any questions about 6 and 8? Because they're going to get harder than this. Rotate to the angle, find the ordered pair. Sine is the y value, cosine is the x value. Any questions about 6 or 8? Let's look at number 10. 10 is asking us for the tangent at 0 radians. Well, we don't have to rotate to get to 0 radians. What's the ordered pair at 0 radians? 1 comma 0. Tangent is y over x. So that would be 0 divided by 1. Tangent is y over x. So at 0 radians, the ordered pair is 1 comma 0. So that would be 0 divided by 1. Is that 0 or undefined? 0. When do you get undefined? When 0 is on the bottom. All right, number 12. Math teachers are all different. We all think different. We're all individuals, but I'm just going to show you how I do this one. All right, I think about what cosecant is the reciprocal of. 12 is asking us for the cosecant. Cosecant is the reciprocal of what? Sine. So I'm going to rotate to 4 pi over 3. I'm going to find the y value, and then I'm going to do 1 over the y value. Cosecant is the reciprocal of sine. Rotate to 4 pi over 3. What's the y value at 4 pi over 3? All right, so cosecant is going to be 1 over negative square root of 3 over 2. Cosecant is the reciprocal of sine. Sine is y. Cosecant is 1 over y. When you divide 1 by a fraction, we can get real technical here and we can change division to multiplication and flip the second fraction. When you divide 1 by a fraction, guys, all that does is it flips the fraction over. You could have just taken that fraction, which is the y value, and flipped it over yourself. So maybe you just skip this step. Does that make sense? You could just skip this step, and if you're doing cosecant, it's not going to be negative square root of 3 over 2. It's going to be negative 2 over the square root of 3, because cosecant is the reciprocal of sine. So you can kind of just skip that step. But your Algebra 2 teacher taught you something about negative 2 over the square root of 3. It's a big no-no. What's the no-no about that? Yeah, that stinking rule. You can't have a square root in the bottom. So we're going to do that R word called rationalize the denominator. We're going to multiply the top and the bottom by the square root of 3. And our simplified answer is going to be negative 2 square root of 3 over 3. All right, lovely radicals. They appear back to us in Precal. Awesome. Woohoo! All right, flip your handout over. That's the last one we're going to do on the front. Flip it over. On the back, we're going to go to number 20. We're going to go to number 20. I'm assuming that you can do the rest of that little section. A says use the unit circle to find the value of each trig function. B says use even or odd properties of trig functions and your answer from part A to find the value of the same trig function. So I'm going to kind of, not really going to follow the directions here. Let me pull up a unit circle real quick. All right, so it says use a unit circle. All right, use a unit circle. You've got the unit circle memorized, right? So 20A is asking you for the cosine at pi over 3. Cosine at pi over 3. So rotate to pi over 3. Cosine is the x value. What is the x value at pi over 3? X value at pi over 3 is... X value at pi over 3 is... 1/2. Thank you. All right, that's how you do A. I've already really taught you how to do A. Now B says use even and odd properties. I really don't go into even and odd properties. B is asking you for the cosine of negative pi over 3. So when I teach this, most people don't use the even and the odd properties. They just rotate to negative pi over 3. Which way are you rotating if you're rotating a negative radian? Down or clockwise. So if I rotate negative pi over 3, then I am at this point right here. Agree? And so what's the difference between cosine values if you're in the first quadrant or you're in the fourth quadrant? Any difference in cosine values since cosine values are x's? No. An x value in the first quadrant and an x value in the fourth quadrant, those that correspond, like positive pi over 3, negative pi over 3, they're going to be the same x value there. So the cosine of negative pi over 3 is going to be 1/2. So you can really do this A and B just by rotating. Just find your angle. If they're wanting the cosine, give them the x value. If they're wanting the sine, give them the y value, tangent, y over x, so forth. So kind of disregard their odd and even properties. They're just trying to get you to see that those two angles are going to have the same x values. All right? If you were in the first and the second quadrant, then the x values are going to be positive in the first quadrant, but negative in the second quadrant. That's all odd and even properties are. Most of my students, if I teach you those properties, you just rotate anyway. Y'all just go find the angle. So just find the angle on the A and the B part in that section. All right, let's get down to sections 25 through 28. This is the part that you're going to have to add some information on a sheet of paper. It says use identities to find tangent, cosecant, secant, and cotangent. All right, we need to write these identities down. All right. One type of identities are called reciprocal identities. You will have to have all this information memorized. All right, one type of identity that we're talking about is reciprocal identities. We've kind of already talked about reciprocals. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, all that kind of good stuff, but we're actually going to write these down. So, sine of angle T is equal to 1 over cosecant of angle T. Cosine of angle T is equal to 1 over secant of angle T. Tangent of angle T is equal to 1 over cotangent of angle T. This looks different. It's still the same thing that I showed you a while ago. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. But the identities look a little bit different. All right. Then we have cosecant. If we know the cosecant, we can set it equal to 1 over sine. Again, because these are reciprocal identities. The secant of an angle is equal to 1 over cosine of the same angle. And cotangent of an angle is equal to 1 over tangent. It's not going to make a whole lot of sense right now. Those are considered your reciprocal identities. We've got 3 different types of identities. We have reciprocal identities. Who's still copying? Okay, hurry. All right, the next type of identities is called quotient identities. There's not as many of these. Quotient identities. many of you know Riley Lefevre? She is at UNA. She came up to me in the fall of her first year at UNA, and she said, "Oh, Ms. Prater," she said, "all that stuff you taught me in Precal, every bit of that was in my first math class, and everybody was so lost, but I knew every bit of that." She said there were some people that didn't even have the unit circle memorized. It's going to pay off in the long run. Y'all just hang on. All right, so one of our two quotient identities, there's only two. Tangent is equal to the quotient of sine over cosine. We kind of already talked about that. We said tangent was equal to y over x. So sometimes they replace sine for y and cosine for x. That one's considered to be a quotient identity because you're dividing two things to make it equal to something else. So I bet you can tell me what cotangent is equal to. What is cotangent equal to? Since it's the reciprocal of tangent, it's equal to cosine divided by sine. You can sin. That's not good, but you can call it sin, but it's really sine. People have been sinning in Precal for a really, really long time. All right, those are your two quotient identities. Tangent is equal to sine over cosine. That's really the same thing as y over x. Cotangent is equal to cosine over sine. We'll do something later on called verifying identities, and you'll need to have these memorized. All right, anybody still copying? One more thing, the Pythagorean identities. This is something else that we have to memorize. Okay? Looks a little bit like the Pythagorean theorem, but it's not. All right, so we have the Pythagorean identities. There are three of them. All right. The first one says sine squared of an angle plus cosine squared of an angle is always equal to 1. It's a very important little identity. It helps us solve problems. It's the most common one. It's the one that sometimes pops up on the ACT. How many of you ever remember something similar to this, sine squared plus cosine squared equaling 1, pop up on the ACT? Every once in a while this will be a trig problem that pops up on the ACT, and now you're going to know what it means. The second Pythagorean identity is 1 plus tangent squared of an angle is equal to secant squared of the same angle. 1 plus tangent squared of an angle is equal to secant squared of an angle, and there are only three. And the third one is 1 plus cotangent squared of an angle is equal to cosecant squared of the same angle. Alright, it's going to take a while, but you're going to start to memorize these. Everything that's on the front of your notes and every identity that we just wrote down needs to be memorized. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. Anybody still copying? Alright, back to your handout. Let's look at number 26. Number 26 says the sine of angle T is equal to 3/5, and the cosine of the same angle T is equal to 4/5. The directions say use your identities to find the tangent, the cosecant, the secant, and the cotangent. Okay? So let's do tangent first. Tangent is sine over cosine. Tangent is sine over cosine, or y over x. Sine is y, cosine is x. If you want to take your calculator and do 3/5 divided by 4/5, or if you can do that in your head. If your sine is 3/5 and your cosine is 4/5, your tangent is going to be, say it louder, 3/4. The next thing that they're asking you to find is cosecant. I'm going to use my reciprocal identity for cosecant. Cosecant is the reciprocal of what? Sine. So I'm just going to take the sine value and flip it over. So that would be 5/3. The next thing they're asking me to find is secant. Secant is the reciprocal of cosine. So I'm going to do 1/4, or just flip that over. That's going to give me 5/4. And then lastly, they're asking you for the, did I miss tangent? No, we did tangent. Lastly, they're asking you for cotangent. So cotangent, you could do cosine over sine, or I like to go back to tangent and just flip tangent over, because cotangent is the reciprocal of tangent. That would end up being 4/3. Okay. These problems can get a little bit harder if you ever end up with a radical in the denominator. If you end up with a radical in the denominator, then you will have to rationalize. Okay? I was going to do number 28, but I'm running a little bit short on time, so I'm going to not do 28, and I'm going to skip to the next set of directions. The next set of directions for 29 through 32 say theta has to be between 0 and pi/2. That really doesn't have anything to do with how you're going to do the problem right now. It says, and sine of t is given. Use the Pythagorean identity, sine squared plus cosine squared equals 1, to find cosine. So in number 32, if you'll just kind of forget about thetas between 0 and pi/2, that kind of looks scary. If you'll just take what they give you, they're giving you sine here. They're even telling you which identity to use. They're telling you to use that sine squared of theta plus cosine squared of theta is always equal to 1. And they're asking you to solve for cosine. So they're walking you through this problem. They're going, hey, I'm giving you sine. I want you to use the identity sine squared plus cosine squared equals 1. And I want you to solve for cosine. So we're going to put sine into our problem. This identity says we have to square the sine. So we put in square root of 21/5. We have to square that. We write down the rest of the identity. Plus cosine squared theta equals 1. Square root of 21 squared is just 21. Square root of 5 is 25. We're solving for cosine. So we've got to get this little cosine squared by itself. So what would we do next? Subtract 21/25 from the 1. So think of 1 as 25/25. Subtract 21/25 from that, and you're going to get cosine squared is equal to what? 4 over what? 25. Now that's what cosine squared is equal to. You only want to know what cosine is, so you're going to take the square root of both sides. The square root of cosine squared is just cosine. And the square root of 4/5 is 2/5. So the cosine, that's what they were asking you for, is 2/5. Now, I'm going to stop my recording right now.